My name's Carrie Roberts. A little about me, I was an engineer for HP for 10 years, and then they started laying off mechanical engineers and hiring computer scientists. So I switched careers and became a computer science major, and went back to HP and started doing mobile app development and PC app development, and ended up as a web app developer for a few years. So I was developing a new product. I was mainly the only developer, so this whole web app that was soon to be released was my code. And management had a pen test done. At the time, I didn't know what that was, and I didn't even realize it was going on, but my manager walked by and dropped a report on my desk and says, "Here, fix this red stuff on here." So I pick it up and I look at it, and it says, "This app is laced with SQL injection." I'm like, "What is that?" And it's like, "We could just do this and delete your database, read your database, whatever." I'm like, "Seriously?" And I go to my desk and I try it, and I just like turn to a ghost, and I'm like, "What the heck is going on? I've never heard of this. I just got out of computer science school. How come they didn't tell me about this?" And you know, there were other big problems too. So I really hung my head and dropped my shoulders, and my husband remembers the day I got home. That day I was like, "Oh, I stink. I can't be a developer. I don't know anything about security." And he encouraged me to go learn about security. So I took a secure developing class from SANS. I was really impressed with that. I started feeling a little better about things. It was actually really easy vulnerabilities to fix if you just knew that you needed to worry about these things. So we got that all fixed up. I decided that the training was so cool that I wanted to go on and do a lot more from SANS. I got the SANS Masters recently, and am feeling a lot better about things than I was that day. I started out as a pen tester for Black Hills 3 years ago, and I owe so much to John and the Black Hills team for giving me a start and for everything I learned from them. I recently moved on to the Walmart Red Team for a chance to do red teaming full-time, and that's been a blast too. I'm a mother of 6 kids, and I just had to clarify because we did have puppies this week, and they're all boys except 5. And my Twitter handle is or1=1, and that's just a tribute to the vulnerability that started me down this whole fun career path. So today I'm demoing the domain password audit tool, which you feed it information from your domain controller about your password hashes, along with any passwords you've been able to crack, and it generates an HTML report. It's a Python script, and it's available at that GitHub location and for anyone to use. And it just makes this HTML report that says how many hashes you have, how many you're able to crack, how many are unique, how many of the weaker LM hashes were stored, what are the lengths of the passwords you cracked and the quantities of those, what are the top passwords used, and who's reusing the same passwords. And it's interactive, so you can click on the details to find out more about each of those categories. So here on CLR 208/DPAT, you can find the code. In my humble opinion, it has an awesome README that tells you everything you need to know about using this, including a link to where I have the sample report. So this is an example of the report that gets generated when you use this tool. It's a Python script that will take information that you've dumped from a domain controller, so usernames and hashes, in combination with a password cracking file. So you try to crack those hashes, and you combine those 2 pieces of information together to get this interactive HTML statistics report for password usage. I've posted the sample report right here at dpat.website. You can go there and play with the sample report if you would like. So on this site, we've got a link to the sample report here, and also the sanitized version of the sample report, which we'll talk about how to make those. But before we jump into the report, we need to understand a few things about the data we're looking at, including the difference between the two types of hashes, LM and NT hashes, that you'll look at. So when we dump information from a domain controller, we get information in this format. It comes in domain/username and then colon RID, which is ID number, and then colon the LM hash and colon the NT hash. So example line item would be like test.local would be the domain, Freddy Fish would be the user, 12345 is the RID, and this whole box here, the green and blue together, is the LM hash, and then the last entry, FF through AF, is the NT hash. So we've got usernames and an LM and NT hash for each user. So the LM and NT hash are both a hash of the same password, but the LM hash is much easier to crack. So it's a weakness if, in terms of security, if you're storing a valid LM hash for the password, because it's so easily reversible or crackable. So we'll talk a little bit about the LM hash. We take an example password like admin guru here, and to create the LM hash, what happens is the algorithm takes the first 7 characters and it turns them into uppercase, as shown here, admin GU, and then it hashes just those 7 characters in uppercase and gets this value FB through 9C. And then it takes the right 7 characters, in this case just RU, hashes those and gets a hash of 022 through 6E. And then it puts those 2 hashes together and puts them as the LM hash. So we got the left half of the password, the right half of the password hashed. And LM hash can only be used when the password is 14 or less characters. So that's an important detail about hashes that we need to understand when we look at the statistics in the report. In the case that the domain controller, the Active Directory, is not storing the LM hash, it will put a dummy value in here. It's actually the hash of blank. So if we search for blank LM hash, it's easy to find out what that is. It's this value AA3B blah 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 blah, ends in EE. That's the value that will be put in there in the case that the Active Directory is configured not to store the LM hash. It'll put that dummy value or the blank hash. Okay, so now that we understand that, let's
Ray says hopefully most folks have disabled their LM in their AD by now, which is true.
Yeah, hopefully they have. I have yet to find a password hash dump from a domain controller that it doesn't have some LM hashes in it. They may be required in that environment for reverse compatibility, and a lot of times there's only a few hundred, but I still see some on a regular basis. So if we go to the sample report, we see that we've got 88,803 hashes that we're analyzing in our sample data. And just a warning, if you click on these details, if any of these first 3 details, since there's 88,000 rows, it takes a while to load. I'm going to start loading this to look at later, but it will take a minute to load all that into one HTML page. And then the next column shows you how many of those password hashes are unique. So this indicates how many users are sharing a password. And then the next 4 lines just show counts and percentages of hashes that we were able to crack. So in this case, we cracked 78% of the hashes. And then you can optionally pass in a list of members of special groups, whatever groups you want. So in this case, I passed in a list of domain admins and enterprise admins. And we can click here for more details. So for the domain admins group, this is slow. Haven't done this with other people clicking on stuff at the same time. Okay, we'll come back to that. So I'm going to open this in a separate tab. And also the enterprise admin. So then we go down, and this is why we needed to understand the LM hashes.
So we have 227 LM hashes. So this is common. I see out of a large domain, there'll be some LM hashes. In this case, there were 227. 226 were unique, means that two users shared the same password and had an LM hash there. So, and then I like to report on what passwords were I able to crack only because I had the LM hash. So I mentioned the LM hash is much easier to crack. You can crack all possible LM hashes within a few minutes, where the NT hash may take forever to crack, depending on the complexity. So in this case, there were 6 passwords we were able to crack because we had the weak LM hash. If we hadn't had the weak LM hash, we wouldn't have cracked it. So in the time we spent cracking NT hashes, we didn't crack it, but we did crack the LM version. And then we have some password length stats. We'll see if this is going to load. Yeah. And then, so it has the password length, 1 through whatever the different password lengths are. It has how many people are using that length of password. And of course, this is only for the passwords we were able to crack. If we couldn't crack them and we only had the hash, we don't know how long the password is. If you want details on those, like who is using a 2-character password, you click the details and it lists the 3 users who are using a
Oh
2-character
man.
password.
But there's some guy out there using a 1-character password.
Yeah.
Hey, Bill had a question. Sorry about all that noise. Bill had a question. So if someone has a password with 15 characters or more, there would be a blank LM hash, and therefore it would be uncrackable? Question?
Oh, sorry. Yeah, there would be the blank LM hash, but it's not necessarily uncrackable. It's just that it takes a lot more computing resource to crack the NT hash. So um, the LM hash is broken to 2 7-character passwords. So in order to crack it, all you have to do is try all possible combinations of 7-character passwords, which doesn't take too long. But you get up the number of combinations increases exponentially. So if now you're trying to do all possible combinations of a 15-character password, that takes years. So to crack that full NT password could take um, an unreasonable amount of time to crack. So we try.
Basically not worth it.
So what we do in that case when we're cracking NT passwords that are longer is we're using a password list. Say here's a common password like based on other password breaches in the past. We say people really like to do a password of let us know. And so that's a longish password, one that would take a long time to get if you're just brute forcing all possible combinations of that many characters. But since it's something that people are likely to use, it's using dictionary words, we could probably crack that NT hash. So if we look at this one that is 39 characters long, oh, it doesn't have the detail there. We'll see it later, but some passwords are predictable based on human nature of guessing passwords. So longer NT hashes are crackable if we can guess what that password might be.
There was one more question from Kevin. What about a blank NTLM? Would it show password length of 0?
Yes, but I'm not showing those. There's usually is commonly passwords in the environment with a password length of 0 because it's a blank password. And I've not shown these on the list. Typically, those aren't able to be logged into in an environment, so I just haven't listed those here. If the NT hash is the hash of blank, then the password actually is blank. And then the second table here is the same information but sorted by descending count. So we see the most passwords are 6 characters in length, then next is 7, 8. So it's just a different look at the same data. Okay, and so top password use statistics. Welcome 123 was used the most, 407 times, winter 1633. So this lists the top 20 passwords used in the environment in terms of how many times people used it. So this can often point to what the default password is for new users or some shared account for conference rooms. And so that can be a good indicator of something going on in the environment. And then the last one is password reuse stats. So it's similar information, but you can see the details like who all is using this password of Beach Bum. There's 16 people, and you can see who those are there. This page this page loaded. This was our details on domain admin. So this link here on domain admins right here, this link, it finally loaded over here. And so it has the usernames. All of these are domain admins. There's 36 of them. And then it shows the NT hash here. And then it lists the users sharing the same hash and account of how many are sharing that same hash. So in this case, it shows that Agnes.Aarons has the same password as Agnes.Aarons/admin. So this is a common thing we see too. It's a good practice in an environment to have regular user accounts and domain user accounts. So Agnes Aarons has her regular user account when she's doing her day-to-day work stuff, and she only should use her Agnes.Aarons/admin account when she needs to do something that requires domain administrator privileges. So it's separation of duties there. If she doesn't commonly use the -admin account, it's less likely to be exposed or discovered through an attack by an attacker. And it's often that organizations will tack on something like -admin or DA to signify that this is the admin version of this person's account. So this helps us look to that. And so we see that Agnes Aarons is sharing her password. She's using the same password for her regular account as her domain admin account, and that voids all the efforts the organization is making to try and protect domain administrator credentials. So that's something we can report on and say it looks like you have domain administrators using the same password between their non-admin account and their admin account. So in the password column, we have the password if we're able to crack it, or blank if we weren't able to crack it. And in the non-blank LM hash column, we say whether there was an LM hash stored for that user. So we have one user here who had this domain admin has both the LM hash and an NT hash stored. And there's also an interesting item here. The share count is 2 here, but it's shared between Abby Adlin and August McGinnis. So that's probably just coincidental that those 2 people shared the same password. It isn't necessarily a non-admin and a regular user, same user sharing a password. So that provides the details on that. And then I mentioned that it takes a while to load these bigger tables. So I had clicked on this link to list all the password hash details, and I got this. So I got username, password, password length, NT hash. It's sorted by password length descending, so you can see the password lengths getting smaller. You can scroll through here or search for interesting words if you're wondering who has spring in their password name.
These lists of passwords always depress me because they're so similar and so lame. We had a couple questions, Carrie, for you real quick. How complex can the passwords be for your cracker? Because it seems like you have some crazy complex passwords here that you know.
Right, so keep in mind that this is sample data. So I took the Rocky list, it's a common exposed password list with thousands of entries, and I contrived a password cracking list. So I randomly select passwords out of there, and I randomly decide whether to put it in the cracked file or not. So basically I said 80% of the time put it in the cracked file as if we cracked it, and not. So it is just sample data. On the same point, I do commonly get up to 20 character passwords, at least a few, when I am cracking real hashes, because they are common phrases that people tend to choose, like somewhere over the rainbow or something like that. So hopefully that answers that question.
Well, if you were using this program for enterprise, how long would it take to generate this a report?
Well, if you've already got the hashes from the domain controller, I typically spend 3 days trying to crack the NT hashes. And of course, I crack all the LM hashes because that only takes a few minutes. And I get in the range of 50% cracked in 3 days. But in terms of running this script, once you have the crack file and the hashes from the domain, it only takes a few seconds to run this, even on the 88,000 entries that we have here.
Cool, awesome.
Okay, so let's go back. Okay, so I think I've gone over all the statistics that are found here. Or there is one more thing. So if we look at the details of the domain admins that got cracked, these are all the ones we cracked of the 36. There is this extra column, only LM cracked. So here's a perfect example of a password. This would be hard to crack as an NT hash only because it's long and it's random. So brute forcing that to make all possible guesses of that long of a password and then checking against the NT hash will take a super long time. But since the LM hash was stored, we were able to crack it. So if there's a 1 in this column, it means the only reason why we have this password in this data is because the LM hash was stored for this user. And that's a point I like to make on the report for the customer. Okay, so if there's no more questions on the actual interactive report, we will proceed to show how to actually use this. So we go back to the...
There is one more question.
Okay.
Does this program generate just HTML reports, or is it possible to have these stats as JSON XML files?
Currently just HTML report, but if you want to come in here and add a feature request onto here, I'll consider adding that as well. So you can give me your requests and feedback for useful features that way.
Awesome.
Okay, so we come in here and we want to clone this or download this repository to get the code. So we're going to copy that and we're going to go in and we're going to clone that repository. And I'm working from a fresh install of Kali 2016, the pen testing VM, and you'll see that useful things are installed by default, including the Git program and some other programs we'll use to get the data we need for the DPAT tool. So we have the data now, or we have the script and the same sample data. That gave us a folder full of sample data, and it gave us the Python domain password audit tool script. So how do we get the data we need to feed to the script? I included on the README a way to do this. There's multiple ways. This was an easy way. This is kind of a go-to foolproof, always works kind of way, and it was also easy to document in the README. The actual easiest way to do it that I know of is through a Metasploit session, but we're not talking about that here. And this is a way that tends to always work. So in order to dump the hashes from a domain controller, you need administrative access to the domain controller. So if you log into the domain controller and start up a command prompt and enter this command, it uses ntdsutil to make a copy of the database, which is called ntds.dit. So we need a copy of that. And we also need a copy of a few registry settings. And this does that all for us, this simple command. It's going to write it to the ctemp directory, so you want to make sure that that directory exists, or you could choose a different directory to write it to. And you also want to make sure there's enough disk space left on the domain controller to make a copy of ntds.dit. So find the current ntds.dit, make sure you have that much room, plus a little bit more because you also are making a copy of some registry hives, but those are small. So I'm not demoing this exact thing on a domain controller today, But if you do that, you end up getting two directories in the temp directory on the domain controller, an Active Directory folder and a registry folder. Inside the Active Directory folder is ntds.dip file. That's a binary file that contains the database full of information we need, and data in that database is encrypted. In order to decrypt it, we need some values from the registry, from the system registry. So this tool also made a copy of that. If we look in the registry folder, we have the system hive. We need both ntds.dit and the system hive in order to extract the hashes. So we run that command I showed you. We copy off the two directories it gives us, Active Directory and Registry, and then we have all the data we need to work with this offline. Okay, and then in order to get the data we want out of that file into human readable format, we're going to use secretdumps.py. And I've got a link to that script there from Core Security. And so this Kali VM, a default Kali VM, comes with secretdumps.py installed and ready to go. We just need to find it. So if we do locate secretdump.py, we find it in the user share directory. So we're going to run that on our ntds.dip file. And this example down here, we're following this right here. We're running secretdumps.py. We're handing it our system registry and our ntds.dip file and telling it to write to a local file. We'll call it customer, the base file name. So we're going to pass it our system file, which is at, and our ntds file. Give it an output file name. Okay, so this is gonna read that data out that we need and put it in the format we want, which is domain/user ID or username, the RID, the LM hash, and the NT hash, like we talked about previously.
Carrie, there's a couple questions. Even Paul asks, even if AD doesn't store LM hashes, I heard RAM on local computers store 14 character passwords or less in RAM as LM. Not sure if you will touch on this subject.
Yeah, that's a little bit out of scope of this. It's true that computers store that in RAM, and you can use Mimikatz to grab that. It's just of recently logged in users, so you could hop around, pivot around in the environment, picking those off wherever people have logged in. There are protections against that in Windows 10 and various workarounds, but again, we won't be covering that here. So here was there another question?
What's the best method to dump hashes in a DC without bringing down production? Shadow files from Micah.
The safest ways that I know of are making a volume shadow copy or using ntds util, which is the example I gave. I believe that the smart hash dump, the smart domain controller hash dump, I forget what exactly it's called in Metasploit, does one of those two methods and therefore would be as safe. I haven't used that as much. Anything else?
Ray says, geesh, I've been making this harder on myself than it needed to be. I'm glad I was able to squeeze in this webcast. So thanks, Ray, for coming. I hope it's super helpful to a lot of people.
Yeah, sweet. I'm glad to hear it's useful. You never know when you sit in your little office every day whether it's helping anybody, but that's good to hear.
Right.
All right, so let's see, that's done, and it's created 3 files for us. The one we want to use is the customer.ntds file. And so if we look at that, it's got the data in the form we need: domain/username, RID, LM hash and NT. So this is the LM hash and the NT hash. Notice you might recognize this LM hash A, D, 3B, blah, blah, blah. That's the LM hash of blank. So in other words, none of the passwords in this little example file had the LM hash stored because they're all this blank value. But that's how you end up getting customer.ntds that you feed to the DPAT tool. So let's back up and go into the DPAT tool that we just downloaded from GitHub. We've got a sample data directory where we've got sample customer.ntds file, so that you can try this now without actually having real data. And we're going to run this, but just as an example, we're going to create a blank or an empty POP file. POP file is typically the extension of a password cracking file. So we're going to just start with a file where we haven't cracked any passwords. Maybe we don't know how to crack passwords and get that file right now, or we just don't want to crack passwords right now. There's still some interesting data the tool can give you without any cracked passwords. So we're going to just create that empty.pop file, and we're going to run dpat. We'll do it with the -h option to get the help, and we see that it requires an NTDS file, which we pass in with -n, and a crack file, so a POP file from OCL Hashcat or John or anything that can get it into one of the same formats. We pass in crack files. So let's do that. We're going to pass in from our sample data customer.ntds, and then for a crack file, we're just going to use this empty file. And ask if we want to open the report, and we say yes. So here we're reading from a local disk, and we have our typical report here minus the group membership information because we didn't pass a list of groups, so we don't have the list of domain admins, we don't have the list of enterprise admins, but we still have the hash counts. We have the LM hash count, so that's interesting data we can get without even cracking passwords, and we can also find out about password use in the environment without cracking passwords. So if we go to the details of that, it doesn't list the password, but it does list the NT hash, and so we know that 407 people are using the same hash, which means they're sharing a password, and we can see who are those people sharing that password or users. So some interesting data that we can get. We also notice this big warning up here. It says, warning, there's 226, so right here, unique hashes which you don't have the password for. And it says it's really easy to crack these LM hashes. You should do it, basically, is what it says. So it gives you an example. If you're using OCL Hashcat, use this command. It'll crack all possible 7-character passwords. Or if you're using John, try this, passing in a format, telling it to crack the LM hashes. This won't necessarily crack all the LM hashes because it depends on what's in the word list. This is a word list attack versus a brute force attack. There's probably some John command you can use to crack all possible LM hashes. I don't have it handy here, but this example, how you could crack some. Okay, so we have that. Now let's go back and use our actual sample. OCL hashcat.pop file. So if we do that, this is how long it takes to run through 88,000 entries. It doesn't take very long. It's asking us if we want to open the report. It also makes note that it's cracking 5 NT hashes where only the LM hash was cracked. So any time it finds that we have LM hash data, partial LM hashes. So when the LM hashes are cracked, it cracks the left half and the right half, but it doesn't put them together. So this DPAT tool will take the left half and the right half, put it together, increment through all the case combinations of that password, and then figure out which one is correct. So it actually does some work for you, and finishing finishing off the cracking of those LM hashes. So if we view this report, we're back to the same data we had on the sample report at dpat.website minus the group membership information. So now let's talk about how to list statistics for specific groups. If we go back to the README, it talks about this, that the group memberships needs to be a file of domain/username. So one domain/username per line. And so in our sample data, we could show that domain admins, we've got username or domain/username in a file called domainadmins.txt. So that's what we need to feed group information to the DPAT tool. So there's various ways to get this. If you're on the Windows domain, you could use the netgroups command and give the name of your group. And that will output it to the screen. You could write it to a file, but it's kind of annoying because the users are listed in 3 columns. So you have to manually massage that to be 1 column, and then you have to add in the domain / in front of each username. So that's kind of a pain in the neck, but possible. And so back on the README, I list the way I like to do it. I like to use the PowerView PowerShell script to read that data using PowerShell. And here's an example of how do you use it. There's a link to PowerView here. You just do get net group member and pass it a group name, and you write that to a file. And the output of that file, I've got an example in the sample data as well. It's called Enterprise Admins PowerView output. And you can see it's a different format. It has the domain listed here and some extra data, or domain right here and username here. But the DPAT tool will pull that out of the PowerView output. So you can feed DPAT this output from PowerView, and it's easier than manually massaging that other list, and so that works for that. So we're going to go back and do our previous DPAT command, but this time we're going to pass in the groups from the sample data. We'll pass in domain admins, and you can pass in as many groups as you want here. Just keep adding them on, and we'll add enterprise admins. And yes, we'll open the report. So now we have exactly the data we have in the sample report. We've got group membership information. The name of the group is taken from the file name. So if you were to use that file called Enterprise Admins PowerView output, that would actually be the name of the group here. So you want to name that group, the file, the name that you want to show up here in your report. Okay, so before we move on, are there questions we need to answer on that?
There's a few questions. I really couldn't say if they were about that, but we'll just go through them. Stuart wants to know if he can get the Python code.
Yeah, it's right here on GitHub, CLR 208/DPAT. You just can clone or download that using this button here, or you can look at it here, dpat.py. There's a Python code.
Okay, cool. And Dominique had a comment, just a remark that using Metasploit tool on domain controller, we meet our error during NTDIS is more than 5 gigs. So we use shadow copy that is more stable and less scary. Sysadmin?
Exactly. Yep.
Okay.
I'll second that.
Nice. Okay. And Andrew said, so if I use NTD SUTIL, I don't need to make a shadow copy. Is that correct?
Correct.
Okay. And David said, awesome, I'm able to follow along on my Kali VM. This will be a great help in my analysis for my work. Thanks for joining, David.
Sweet. Yeah, thanks for the positive feedback. Okay, so moving on, let's just look at a couple of other options that DPAT has. Let's do it with the help. So we're going to look at these two additional options. We've got the sanitize option and the write DB option. So the sanitize option, you simply tack on -S, and it'll give you a sanitized version of the report, which redacts the hashes and the passwords in case you want to share this with the organization or someone else. If we look in this case, all the NT hashes are start out in the middle, only showing the first 4 and last 4, and any passwords only show the first character and the last character. So that's true of the entire report. So that's what the sanitize option, it just, the report typically goes in the DPAT report directory, but if you do the sanitize report, it adds sanitize dash in front of it. So if we list files here, we've got a regular DPAT report, and we have our sanitized DPAT report. Inside of the DPAT report directory is all the HTML files that build that web page. Okay, and the other thing we wanted to look at was the write database option. So the way the Python script works is it builds an in-memory SQLite database. And that's how it searches through all the data to get the statistics. If you would like to write that database to file, you can do that by adding the -W option. That's handy if you want to look up, you want to interrogate the database and look up other things that I might not be reporting on in the HTML report. So let's try that. Whoops. We're gonna write the data to the file, to a file, and right here it says, but the file name will be passaudit.db. So we run that, and we go into our DPAT directory, and now we have this passaudit.db. Now Kali doesn't have a SQLite browser with GUI by default, so I installed this DB browser for SQLite from sqlitebrowser.org, and super easy to install on Kali. You just do, where'd it go? No, I can't find it. There it is. apt-get install SQLite browser, and then you will have the browser. It won't necessarily be associated with DB files. You might have to start the browser and then click File Open. I've associated it as an extra step, so I can just double click on the file here, and it will open it in the SQLite browser, and we can browse the data. Here's all the data: usernames, LM hashes, LM hash left and right, NT hash. So if we wanted to look for something interesting here, we could say in the password field, who's using the word spring in their password. So we see these users using the word spring. Or we could say, if we're looking for user Bob, here's all the users with Bob in their name. We could go and execute custom SQL queries against this database. So we could select everything from the main table where password is not null, for example, so all the passwords we cracked, and we could order that by password descending, so alphabetical order descending. Whatever we might be looking for, we could do here by interrogating this database. So now we have all the users whose passwords were cracked, and they're sorted reverse alphabetical. So if there's something specific you're looking for, you might like that option. Okay, so I'm realizing there's one part I forgot to show, which was how to crack passwords. So we're going to do that as an example. We're going to use John because that's installed on Kali and it's easier to use out of the box. So we're going to, John is installed on Kali by default, so we're going to run John, and we're going to run it on our sample data, our customer.ntds file. Okay, so we run that and it immediately starts cracking, but it's actually cracking the LM hashes only. The :1 at the end of the username means it's the left half of the password. The :2 is the right half of the password. So when it cracks these, it does it by the left half of the hash and the right half of the hash. It doesn't put the two together, and it doesn't tell you what the proper uppercase or lowercase is. So it's kind of part of the story. And DPAT will finish putting those back together and finding the right case for you. So if we stop this and we scroll back up to the top, there's a little message that says we detected both LM and NT hashes in the file. If you want to correct the NT hashes, add -- format equals NT. Before we do that, we're gonna look at that file. The john.py file by default gets written to the .john directory. We're gonna look at that. So we have John outputs cracked passwords in this format. It does the hash type $LM$, and then it does the hash. So this is only 16 characters instead of 32 because it's either the left or right half of that LM hash, and this is the left or right hash of the password in uppercase. So we actually, from this file, we don't actually know if it's the left or the right, and we don't know the proper case. And that's where DPAT comes in handy. So now let's run John, but we'll crack NT hashes. So here it's cracking all these passwords based on the default password list. And we'll go ahead and stop this. And now if we look at the end of the file, our pot file, we'll see the NT. So we got $NT$. That's John telling us it's the NT hash. And then we have the full 32 character hash. And then we have the password. And this is the actual password in the proper case. And so we have both the shorter LM half of a hash in this file with the uppercase password and the longer full password, the NT hash, all in one file in the john.pot. So let's run DPAT against that data. We will pass it our NTDS file and the sample data, and we'll pass it as a crack file instead of the OCL hashcat.pot. We'll pass it that crack file we just created with John, which was here and john.pot. And we'll run that. And in this case, there was 119 LM hashes cracked where the NT hash wasn't. That's because we spent, we didn't spend much time cracking the NT hashes. So we're going to read that report now. And so we get the warning at the top. There's more LM hashes that you could easily crack. And here's how you do it. But it also gives us the statistics. We were able to crack 10% in that amount of time. And we could get all the details of who that was and what those passwords were. We could get the password length statistics. And we could here's an example of a password it cracked. It didn't crack welcome123. So I think that completes it. We've been through how to dump the hashes from a domain controller, which you need administrative access to the domain controller to do, and you can do that with this utility. That gives you files that you can then feed to secretdumps.py to get customer.ntds needed to use DPAT. And then you want to generate some password crack file, or you can use an empty one, but you'll get less data. And then you use DPAT like this. You pass it the NTDS file, the OCL hashcat.pot, and optionally some groups. And the groups, you can generate those files. The easiest way it was with the PowerShell script here, described here. And the example of cracking passwords, LM hashes with OCL hashcat or John is given here. And then, of course, the help options is at the bottom of the file. For the different options, you can optionally write the database to a file to look at it through a GUI, and you can generate a sanitized report. Are there any questions?
Joseph said he thinks it's a very useful tool, and he also wants to thank you for all your hard work. So I think feedback's been awesome. Thank you guys. And then Marlon says, how and when do you use this on a customer site? What situations would this be requested?
Typically when we're performing a pivot test is when we get given internal access to a network, but we're just a standard user. So if we got hired on or just whatever they hand out to their standard users, new employees, we get given that level of access, and then we try to pivot in the environment and escalate our privileges to the level of a domain admin. And if we're able to do that, which commonly we are, then we offer to the customer to go ahead and extract the hashes from the domain controller so that we can give them useful statistics on password use in their environment. And that's when we do it.